Hey everyone, have you ever wondered where those really game changing ideas come from? Well, today we're going to pull back the curtain on a hidden blueprint for innovation, and you might be surprised to find out it's been right under our noses the whole time. So let's just get right to it. This is the $1,000,000 question, isn't it? How do you build something that's actually new? Is it, a sudden flash of genius in the middle of the night, or is it something else? It turns out a student science club found a pretty incredible answer. They weren't trying to invent something out of thin air. Instead, they just looked at all their normal classes, biology, chemistry, math, and started connecting the dots. And what they realized is kind of mind-blowing. All those textbooks they were studying for exams, they weren't just for tests. They were basically an instruction manual, a secret playbook for engineering breakthroughs, just waiting for someone to put the pieces together. Okay, so let's crack open the first chapter of this secret manual, biology. It turns out nature has already solved some of the toughest engineering problems out there. You just have to know how to look. So, check this out. It's a really simple but powerful idea. A plant, right, it grows wider leaves so it can catch more sunlight to make energy. That's just basic survival. The students saw that and thought, wait a minute, we can do that same exact thing with our wind turbine. And the result? It was incredible. Just by making the blades bigger, an idea they literally took from a plant, they boosted the turbine's energy output by 33%. That's not just a tiny little improvement, that's a huge leap forward. And nature's genius doesn't stop there. I mean, think about how a massive tree gets water all the way up to its top leaves. There's no pump. It uses this silent, brilliant system. The leaves create a tiny bit of suction, and these super thin tubes inside the tree use something called capillary action to pull the water up all the way against gravity. It's a masterclass in how to move fluids efficiently. All right, let's flip to the next chapter in the manual, geology and chemistry. This section is all about the what. What do you build with? Because as they found out, the materials you pick can make or break your entire project. This quote from the student's own journal just says it all. Material selection isn't just about what looks good, it's an efficiency factor. That means everything. The copper wire, the type of biofuel, the plastic, every single choice has a direct impact on how much energy you're going to get out at the end. And here's another great connection they made. In nature, it takes millions of years for geology to concentrate minerals into valuable ore. Well, we can do the exact same thing with energy. Solar power is spread out all over the place, but if you use a lens or a curved mirror, you can concentrate all that sunlight onto one tiny spot and generate a ton of power. And over in chemistry, the kind of fuel you use is absolutely critical. Look at this. The students had to figure out, are they using a solution, which is stable and gives predictable results, or are they using a suspension, where you have bigger particles that can just settle out, clog up the fuel lines, and bring the whole system to a grinding halt? Choosing right is the key to making something that actually works reliably. Okay, time for the chapter that pulls it all together, math. And don't worry, this isn't about crazy complex equations. This is about using math as a tool to find the absolute peak performance of a system, what we can call the sweet spot. And the star of the show here is the parabola. You know, that U-shaped curve you probably learned about in math class? Well, it turns out it's basically a treasure map for engineers. For so many things, performance goes up, it hits a perfect peak, and then it starts to go back down. That peak, the very top of the parabola, is exactly where you want to be. And you can see it right here with their turbine blades. The students tested different angles. At 3 degrees, the output was pretty good, 92 joules. At 7 degrees, it was basically the same. But math helped them predict that the sweet spot would be right in the middle. And sure enough, at exactly 5 degrees, bam, 100 joules, the maximum possible power, found with math, not just guesswork. So, after going through biology, chemistry, and math, what's the big lesson here? What's the real secret ingredient that this hidden manual reveals? Well, the secret is that none of these subjects work alone. Biology teaches us how to design things efficiently. Geology and chemistry give us the right tools and materials. Physics helps us understand the fundamental forces at play. And math gives us the precision to optimize the whole thing. Each subject is a critical piece of the puzzle. And that's really the heart of it all. What those students found is that the ultimate superpower isn't being an expert in just one thing. It's the ability to see the big picture, to connect the ideas from all the different fields. That is where real innovation is born. So it makes you wonder, right? What connections are hiding all around you and your own world, just waiting for someone to notice? What dots are just waiting to be connected? Think about it. Thanks for joining me.